Hello and welcome back. We're going to start a new unit here, and this is going to be Chapter 5, and this is polynomials and polynomial functions. And so one of the first things that we're going to do, we're going to skip to section 5.3, and we're going to talk about the greatest common factor and factoring by grouping. Okay, so there's all this information here on factoring, and what I want to do is think of the distributive property. Okay, so we're going to start with the distributive property, okay? And what I have there is, let's think if I were to take, say, like 3 times, say, x plus 2, okay? If I were to distribute this 3 in here, 3 times x, and then add 3 plus 2, so 3 times x, and then plus 3 times 2, we're going to get 3x plus 6, okay? Now, when I do factoring, okay, now I think we're all pretty used to the distributive property, so but if I do factoring, that's the opposite of the distributive property. So that's the opposite of the distributive property. All right, so if you had the phrase 3x plus 6, the question is there a common number that multiplies into 3 and into 6? And the answer is 3. So you just go backwards from what you did. So if you said, okay, if I could take out a 3 and do the opposite of the distributive property, then this is factored, okay? And so factored means, the word factor, and let's write that up here. The greatest common factor. Factor means that you multiply things together. So multiply things together. Okay, factor means multiply. So the greatest thing that you can multiply into here, okay, and then you can take that out. All right, so that's kind of, if you understand the distributive property and remember how we do that, then you kind of have to think about when you do factoring as the opposite of the distributive property. Okay, so now what I want to do here is let's take a look at some of these examples. And the way that I look at these, I want to factor these completely. Basically, I want to find what's common in them and take that out, okay? So I have a number of things here. What I'm doing here is I'm taking 2 times y squared. Okay, I'm going to put a little multiplication symbol in there, and I'm subtracting 18 times y. All right, so I want to look at each of these little pieces, the 2, the y squared, the negative 18, and the y. All right, so if I do this, I want to think about all the factors of 2. And the factors of 2 are going to be 1 and 2. All right, those are the two numbers that when I multiply together will give me 2. Okay, if I take the factors of 18, that's going to give me 1 and 18, 2 and 19, I'm sorry, 2 and 9. All right, and then 3 and 6. Okay, so these are all my factors. Now the common factor that I have here is 2. Okay, so I can factor out a 2. Now when I have y as a factor, okay, the common factors of y are just going to be y, and the factors of y squared are going to be y times y. So when I look at my variables and I say, okay, what's common? Okay, I look and see those factors, and it's always the variable with the smallest exponent, and if there is no exponent, the exponent's 1. Okay, so it's always that. But looking at the factors of 2. So a lot of times you can do this in your head, but this is the way that you would actually do that. And so what I can take out is a 2 times y. And you have to think about what are you left with. If you were to multiply 2y times what would give you 2y squared, okay? And so when you factor that out, you're just going to be left with a y. And then minus 2 times what gave me 18, and that was 9, so minus 9. And then we factored out a y. And this is completely factored, okay? And so if you want to check, okay, you can always go back through and, redistribute. So to check, we want to distribute. And so that would just be, if you had 2y times y minus 9, if you distribute that back in, you're going to be left with 2y squared minus 18 times y. okay, and that's the same thing you started with. So those are that example. Let's take a look at something else. Okay, something a little bit more complicated. Now, what I notice with this is I got to find my greatest common factor, which is what we did over here. My greatest common factor, and let's write that here. When you do this, greatest common factor is going to be 2y. All right, so to come up with that. So when I factor this over here, I also want to come up with a GCF, a greatest common factor. Okay, and what I have here is I have to look at all the numbers first, 27, 15, and 3. Okay, 3 goes into all of those. Okay, 15 doesn't go into 3, so my greatest common factor is going to start with the 3. And then I look for my x variable, okay? And I see that, and I want to look for the one with the smallest exponent, and that's this one here with an exponent of 1. Okay, so x, just a single x. And then when I look at the ones at the y, I've got y to the 7th, y cubed, and y squared. I want to look for the smallest one, so it's going to be y squared. All right? And so that's what I want to factor out, okay? And so when I factor this one out, I'm going to write it out here, 3x times y squared. And I have to ask myself the question, 3x times y squared times what is going to give me 27x squared y? And when I do this, 3 times what is going to give me 9. Okay, so this is 9. X times what gives me x squared? That's just going to give me another x. Okay. And then here, y squared times what gives me y to the 7th, and that's going to give me y to the 5th. All right, we'll talk all about exponents here soon. Okay. Okay, now let's do the next one. Okay, so now 3 times what gives me 15? That's going to give me 5. X times what gives me x to the 5th? That's going to give me x to the 4th down here. Okay. And then y squared times what gives me y cubed, and that's just going to give me a single y. All right. And then let's go ahead and put our minus sign in here. 3 times what gives us 3, and that's going to be a 1. Okay, and you can kind of keep that 1 there if you want to. You don't have to. X times what gives me x, and that would be another 1. All right, I don't need to really write that down. Negative 1 times 1 is going to give me negative 1. And then y squared times what gives me y squared, and that would be 1 as well. So because all those are 1s, I only need to write it once, and this is my factored form, okay? And there's nothing else that I could take out of that, all right, or factor out of that. All right, let's take a look at the next one. It says, write an equivalent expression by factoring out a factor with a negative coefficient. So on these are a little bit tricky. So we want to factor out a negative coefficient. Now, my question is here, and sometimes I get kind of tripped up, but I wonder, okay, can I take 16 out of 128? Okay, does 16 go into 128? So to figure that out, I'd say, okay, well, what if I take, 128 and divide it by 16? What do I get? Okay, and that's going to end up giving me 8 after I did that on the calculator. Okay, so I kind of had to figure that out. So that allows me to say that my greatest common factor is going to end up being negative 16, and I'm going to take that out. So if I take out a factor of negative 16, then you have to think about what you'd be left with, all right? Negative 16 times what is going to give me t squared, or negative 16 t squared, and it's just going to give me t squared. Now, the reason why I didn't put a variable in here is because there's no variable here to factor out, okay? I didn't multiply anything in there to give me a variable. All right, so I've got t squared, and then if I factor out a negative 16, I have to put in a negative 8, okay? And here's why. Because when you factor out a negative, okay, if this leading coefficient here is negative, if you factor out a negative from here, then you have to be left with a negative, okay? And you have to, this is one where you kind of want to maybe check yourself just so we don't make sign errors, but if I redistribute the negative 16, it's going to give me negative 16 times t squared, and then negative 16 times negative 8. And that would give me negative 16 t squared plus 128. Because a negative times a negative gives me a positive. Okay, so when you factor out a negative, you got to be left with a negative. Okay, here's your answer for that. All right, let's take a look at part B. All right, and on this one, it wants us to factor out a negative coefficient. So factor out a negative. What I could factor out of here, 7 and negative 35. Okay, 7 does go into 35, goes in 5 times. If I were to factor out a negative 7 from here, okay, because 7 goes into 7 and 35, I can factor out a negative. I'd be left with negative 1. And then I'd be left with plus 30, or plus 5x. Okay, and that would be my factored form. Now we want to check this. All right, and so I would redistribute my negative 7. So if I multiply negative 7 times negative 1 plus negative 7 times 5x, okay, negative 7 times negative 1 is going to give me positive 7, and then minus 35x. All right, and that would be my answer for part B. All right, so, you know, the things that I've boxed, those are your answers, okay? And then, you know, what I'm doing just down below is checking. So remember, we're doing the opposite of the distributive property. Okay, now we've got some other kind of tricky problems here. Okay, on this one, you know, what it's asking for is to factor the following completely. This is where it gets really kind of tricky. Okay, and what I'm going to do is call this factor by grouping. Okay, this is kind of the factor by grouping piece. All right, or the start of it. All right. Now, what I see here is the prompt to distribute. To distribute 3x squared, you know, to multiply this into 2x, multiply it into 9, do the same thing with the 2 and with the 9. But here's what I notice. I notice that all the stuff that's inside of the parentheses are the same. Okay? And I'm multiplying those by numbers. Now here, and for whatever reason, I never grasped this concept, and this is kind of a hard concept to grasp. Because this is in parentheses, this is a quantity, okay? And I'm multiplying that by 3x squared and by 2. I have the same thing here. This is my greatest common factor. This is my GCF. Is the phrase 2x plus 9. This is a quantity. I can act as if this is its own like separate number, okay? So instead of having a number for your greatest common factor, or, you know, a term, we have, you know, an algebraic expression like this, 2x plus 9. So this is what I want to factor out, okay? And what you'll see is that if I factor out a 2x plus 9 here, okay, then what I get as left over is going to be 3x squared plus 2. And this is factored. Okay? Now what you can do is you can distribute this whole quantity back in. Okay? So to check using the distributive property, you would take 3x squared and you would multiply it by that entire quantity, 2x plus 9. Okay, and then I would do the same thing with the 2 times 2x plus 9. Okay, this is a really hard thing, but what you're looking for is that common piece here, okay, that common factor, all right, and that's kind of hard to see. All right, now over here, we don't have that. We have 4 terms, okay, so what I have to do is I have to do factor by grouping, and what I'm going to do is this. And that's going to be changing all of my minus signs to adding negatives. Okay, and you'll see why here in a second. Okay, now what I want to do, the whole concept is to factor this by grouping. Okay, and so what I want to do is I first want to group this. Okay, these 2 terms together, and then I want to group these 2 terms together. Okay, with the plus sign in the middle, and that's just going to help me. And let me rewrite this just so it looks a little bit better. Okay, so let me do, okay, x cubed plus 7x squared, parenthesis, plus quantity, negative 2x plus negative 14. Okay, now what I want to do is I want to look here and I want to say, okay, what can I factor out of x cubed and 7x squared? They have a common x squared that I can factor out. So if I factor out an x squared, you got to think about what you're left with. You're left with x and then plus 7. Okay, the opposite of the distributive property. Now over here, okay, this term has an x, but this term doesn't. but I could factor out a -2 from each of these, okay? And the goal is I want it to match this, all right? So if I factor out, I'm going to do plus -2 parenthesis and then x plus 7, all right? And that's the goal, is I want this to be, let me make this what I factored out, the -2, okay? I want this to be my common factor. So my greatest common factor out of this whole thing now is x plus 7, all right? Now what I can do is I can factor that out, and I'm left with then a common, let me get back here, a common x plus 7 can be factored out, and then I'm left with, change this to red, x squared minus 2, and this whole thing is factored. All right. So we first learned to just factor, you know, binomials, things with two terms or maybe more than one term. But then I look over here and I want to factor out this entire quantity. This is factored by grouping. Okay, and this is that thing. This is what I'm talking about. So typically what you do, you know, is you kind of look at the problem and you say, all right, which one does it look like? Does it look like something like this, or even like this or this? Does it have more than one term? Should I do factor by grouping? Is there a common factor that I can take out of this? And down here in this one, there wasn't a greatest common factor. Okay, there, you know, this had an x, x cubed, x squared, x, and then this didn't have an x. So because this didn't have an x, I couldn't factor out an x to begin with. Okay, so I want you guys to go ahead and get started on that homework down here, and you know, holler if you got any questions. Thanks. Bye.